In this video, we're going to talk about topic 6C, simplifying radicals using imaginary numbers. Before we can talk about imaginary numbers and simplifying radicals with them, we need to know how to simplify radicals and what an imaginary number is. So the first thing we're going to do is review how to simplify the following. So number 1 here, I'm going to start by breaking it down into its factors. So 162 can evenly divide into 2 and 81. 2 is prime, so I like to circle that, and 81 is 9 times 9. Neither of those are prime, so we can keep going with 3, 3, 3, and 3. Now all of these are prime, so they get circles. Then what I like to do is reopen this square root and break down 162 into all of its prime factors. So we had a 2 and then 4 3's being multiplied. And what happens is if there are any pairs, then those get to come out of the radicals. So this should all be reviewed from Algebra 1 and Geometry, but that means that there is 1 3, 2 3's on the outside, which is going to be a 9 because we're multiplying, and then a 2 is left alone inside. Question like number 2 has a square root in the denominator. We can't have radicals in the denominator, so we multiply by the square root of 7 on the top and bottom of our fraction to get rid of that square root in the denominator. And in the top, when we multiply radicals, if there is no radical, then it's just 6 times the square root of 7, almost like a variable. In the bottom, and if we have square root of 7 times square root of 7, that's really the square root of 49, which is 7. So the point of multiplying by that square root is to get rid of the square root. It cancels out because we're squaring a square root, and it's just going to be 7. Number 3 is just like number 1. So I start by just looking at the radical. The 9 we're going to just ignore for a minute. And I think 1,000 can be divided by 10 and 100. Neither of those are prime, so I keep going. 10 can be 2 and 5, and both of those are prime. And 100 can be 10 and 10, which can keep going to be 2 times 5 and 2 times 5, where all of those are prime. So then I go back, and I think about the original problem was 9 times the square root of 1,000, but instead of 1,000, I really have 2 times 2 times 2 times 5 times 5 times 5. And I look for pairs. So I see a pair of 2's and a pair of 5's. So one of those can come out, so that's going to be a 9 times 2 times 5 on the outside of our square root, and a 2 times 5 inside. So when we just multiply all those, we'll get 9 times 10 is 90, and the square root of 10. So that is our review of simplifying radicals. The next thing we're going to review is the number set diagram. So I'm going to go ahead and fill this out. So real numbers are all the numbers we're used to seeing. We use the double bar R to represent that. Irrational numbers, we use this I for that, and rational is going to be the Q. Integers is Z, which is kind of weird, W for whole, and N for natural. So just as a recap, irrational numbers would be things like pi and the square root of 2. Rational is anything that can be written as a fraction. Integers is going to be your counting numbers, including negatives. Whole numbers are going to be 0 and all the positive integers, and natural is just going to be positive integers, so normal counting numbers. The one that we don't know yet is the complex numbers. Complex numbers includes our imaginary numbers, I, and they can be written as A plus BI. An imaginary number is the square root of -1. So the definition of I is the square root of -1. Just like how pi is 3.14159, I is the square root of -1. So when we go to simplify problems 4 through 6, it's just like the way we just did the last ones. So the square root of positive 162 was 9 square root of 2. So this is just going to start with a -1 as we go to do our factor tree, and then we would do the same thing as before. And the square root of -1 is I. So instead of being 9 times the square root of 2, it's going to be 9i times the square root of 2. So the I comes outside. That's the big thing that people usually forget. Number 5 will also be super similar. Instead of being 6 root 7 over 7, it'll be 6i root 7 over 7. So we do the same process. We're just going to have an I in the end, and the I is outside of the radical. Same with number 6. Earlier we got 90 times the square root of 10. Now we're going to get 90i. times the square root of 10. So these next ones we haven't seen yet. So I'm going to start by factoring, and I think of negative 1 and 15, and the negative 1 is important because that's our I. 15 is then 3 and 5. And that's it. Those are all prime numbers. 3 and 5 are prime. Negative 1 is going to be our I. So when I really go to break this down, it's negative 1 times 3 times 5. And we don't have any pairs, but we do have something that can come out of the radical, and that is the square root of negative 1. So our final answer here will just be I times the square root of 15. Number 8, I think of negative 45 as negative 1 times 45. 45 is 5 times 9, where 5 is prime. The negative 1 was done. And the 9 is 3 and 3. So when we break it down, it's going to be the square root of negative 1 times 5 times 3 times 3. I've got a pair of 3's, and I've got that negative 1. So we get a 3i on the outside and a 5 on the inside. Done. I want you to try number 9 before you check out the answer. So I went ahead and broke down the square root of negative 24, and I get a pair of 2's and then that square root of negative 1. So that means we'll get 2i and then a 6 on the inside, and that's our final answer.